Welcome everyone. Let's kick off 2025 with a resolution to build the most comprehensive data science tutorial available online. This is your first step into the world of data science, and I promise to make it insightful, enjoyable, and easy to follow. So, what's in this class? We will discuss Introduction to Data and Data Science, Classification of Data, Methods of Data Collection, Methods of Data Storage, and in end, we will give you some recommendations on learning resources. So let's dive in. What is data? If we look at the definition, it says data refers to raw facts, figures, or information that can be recorded and used for analysis, interpretation, and decision making. In simple words, think of data as building blocks of information. Just like how letters form words and words form sentences, data forms knowledge. Some examples of data are height of the student in class, daily sales of a shop, survey responses like do you like chocolate, and measurement like daily temperature or rainfall from weather station. So how do we classify data? Classification of data. To make sense of data, we need to classify it. Let's break it down into categories with example. So data is broadly divided into quantitative data and the qualitative data. The quantitative data is also called the numerical data. This is data you can measure or count. It answers questions like how much, how many, or how often. Types of quantitative data includes discrete data and continuous data. Discrete data are numbers that have clear gaps between them. For example, number of goals scored in a football match. It can be 1, 2, 3, but it cannot be 2.5. Number of people in a queue. It can be 5, 10, 15. It cannot be 10.5 or 15.5. So think of it like counting apples. You can't have 2.3 apples. Whereas continuous data are values that can fall anywhere on a scale, including decimals. There can be infinite values between a range. Imagine pouring water into a glass. The amount can be precisely measured to any decimal point. Examples include height like 5.8 feet, temperature 36.7 degrees centigrade, speed 65.4 miles per hour. These are some examples of continuous data. Qualitative or categorical data. This data describes qualities, characteristics, or labels. It's not numerical and cannot be used for mathematical operations. Type of qualitative data includes nominal data and ordinal data. Nominal means names. So this data includes categories with no specific order. As you know, names are for identification only. They don't have any particular order. For example, gender. It can be male or female. Nationality, USA, India, Japan. Colors, red, blue, green. They don't have any specific order. Think of it like sorting items into unlabeled bins. Whereas ordinal data includes categories with meaningful order but no measurable difference between them. Example, t-shirt sizes. That can be small, medium, large, but you cannot measure the difference between small, medium, and large. Like satisfaction level, dislike, neutral, like. You cannot measure the difference between dislike or neutral or like. So it's like arranging books by size, but not knowing the exact weight difference between each books. There are some advanced classifications like interval and ratios. So interval data includes data with meaningful intervals but no true zero. That means if the data has value 0, that does not mean the quantity does not exist. For example, if temperature is 0 degrees Celsius, 0 degrees Celsius does not mean no temperature. Ratio data are the data with a true zero, indicating absolute absence. Example, temperature in Kelvin, where 0 Kelvin means no heat, or height is 0 means no height at all. We can also classify data based on how it is organized. If data follows a strict schema, meaning it has a defined set of fields and data types, it is called structured data. Characteristics of structured data is that it is organized in rows and columns, and it is easily searchable and queryable. Example includes customer database, financial transactions, product catalogs, etc. Structured data is often presented in tables or spreadsheets. Data that doesn't conform to a predefined format is called unstructured data. It's often stored in its native format, making it difficult to analyze directly. The characteristics of unstructured data are no predefined schema and difficult to search and query. Example includes text documents, images, videos, social media posts, sensor data. Unstructured data can be challenging to visualize due to its varied nature. So why does these classifications matter? Knowing these type of classifications help us to choose the right tool for analysis and interpret data accurately. Where does the data come from? Let's explore how data is collected in the real world. Here are 16 methods with examples to make them relatable. First method is survey and questionnaires. In surveys and questionnaires, we collect feedback using tools like Google Forms. Second method is web scraping. We use web scraping to extract information from website. There are many tools available for the web scraping. That includes Beautiful Soup, Selenium, etc. Example of web scraping includes tracking product prices on Amazon using Python's Beautiful Soup. API or Application Programming Interfaces. APIs are used to access data from platforms like Twitter or OpenWeather. Example of API includes fetching live tweets mentioning data science. Public dataset. Through public dataset, we can access free dataset from platforms like Kaggle or government portals. Example, using census data for population analysis. Sensors and IoT devices. We can collect real-time data from devices. Example, a smartwatch or a smart home thermostat recording daily temperatures, etc. Social media. Social media can be used to analyze posts for sentiments and trends. Example, finding the most used hashtag in 2025. Crowdsourcing. Crowdsourcing is a method where data is contributed by the volunteers. For example, annotating images for AI training on Amazon Mechanical Turk. Experiments and observations. Experiment and observations can be used to run controlled experiments. Example, testing two website layouts to see which gets more clicks. Company databases. Company databases can be used for internal data like sales logs. Example, analyzing customer purchase histories. Web crawling. Web crawling can be used for collecting data by visiting multiple websites. Example, aggregating news headline from different portals. Open data APIs. Public APIs for sharing structured data. Example includes accessing the World Bank's economic indicators. Satellite data. Satellite data is used to collect information from space or remote sensors. Example, monitoring deforestation using satellite imagery. Mobile apps. App collecting user data. For example, tracking steps on Google Fit. Simulations. We can generate synthetic data. We can ask our computer to generate dummy data based on our experimental requirements. Example includes simulating traffic patterns for a new city design. Manual data entry. These are hand-entered information. For example, logging inventory in a warehouse. And data partnerships. Here, we buy or share data with other organizations. Example, using Nielsen's data for market analysis. Why does this matter? Understanding these methods prepare you to choose the best data source for your projects. For example, if you want real-time information, you can use sensors or APIs. Or if you need historical data, you can check public repositories. Introduction to methods of data management and storage. Data management and storage are foundational components of any data-driven process. Whether you are an individual tracking expenses, a researcher analyzing trends, or a business managing vast amount of data, understanding various methods of data storage is critical for efficient organization, retrieval, and analysis. In this section, we explore key methods of data storage and the file types used in data management. File-based storage. File-based storage involves saving data in individual files that can be accessed and managed on a computer or server. This method is suitable for smaller dataset or when working on a standalone project. Common file types includes but not limited to CSV files, Excel files, PDF files, text files. CSV files also called comma-separated values. CSV files are a plain text file where data is organized into rows and columns, separated by commas. These files are ideal for tabular data like sales records, survey results, or financial reports. The advantages are they are lightweight, easy to read, and compatible with most data analysis tools. Excel files. Excel files are spreadsheet format developed by Microsoft, allowing data storage in rows and columns with additional features like formulas, charts, and formatting. These can be used for financial modeling, data reporting, and visualization. The advantages include user-friendly interface, support complex operations like pivot tables and macros. PDF or portable document format. PDF is a file format designed to present document consistently across devices and platforms. Use case include storing reports, presentations, or formatted text and graphics. Advantages: suitable for sharing finalized documents. Text files. Plain text files for unstructured or semi-structured data. Use case includes logs, configuration files, or storing multiple text data. Advantages are these are lightweight and highly accessible. Databases. Databases are structured system of storing, managing, and retrieving data. These are essential for handling large dataset or multiple user environments and offer advanced querying capabilities. Type of databases include relational database, NoSQL database, vector database, cloud-based databases. Relational databases. These organize data into tables with predefined relationships using a structured format. Example includes MySQL, PostgreSQL. Use cases: customer relationship management, e-commerce platforms, financial systems all use relational databases. Advantages include consistency, scalability, and support for complex queries using SQL. NoSQL databases. NoSQL databases store unstructured or semi-structured data, allowing for flexibility in schema design. Example: MongoDB, Cassandra, Redis, etc. Use case include social media data, IoT sensor data, and real-time applications. Advantages are highly scalable, suitable for big data, and dynamic requirements. Cloud-based databases. Cloud-based databases are hosted on cloud platforms, offering remote access and automated maintenance. Use cases include SaaS application, document management system. These systems specialize in storing and organizing various document formats. Example: SharePoint facilitates collaboration and document sharing in organizations. Google Drive, cloud-based storage for personal and team use. Dropbox simplifies file synchronization and sharing. Use case includes centralized document storage for team, secure archival for legal and compliance documents. Why choosing the right storage method matters. With right storage methods, you can have efficiency, scalability, security, and cost effectiveness. In our next videos, we will talk about these topics: data cleaning and processing, exploratory data analysis, visual techniques, and machine learning basics. We will cover these all topics in the month of January. And as promised, here are some recommended learning material to get started. Thank you for joining me today. If you found this helpful, like, share, and subscribe. Let's make this journey enjoyable and insightful together. See you in the next class.